Building the first utility-scale solar project in Greece sounds exciting, until you realize there is no blueprint, no regulations, and no local supply chain. How was it even pulled off? Let's watch on Sailing the Storm, only on ENF TradeTV. Welcome to Sailing the Storm on ENF TradeTV. I'm your host, Trambak Chatterjee, and today we have another spectacular episode with Interphoton, a leading company from Greece who talk about their journey, challenges and innovations in the field of solar installations. Hello Eleni and George, a warm welcome to our show. Could you introduce yourself and your company?
Hello Trambak, thank you very much for having us at the show. I am Eleni Zafiradou. I work as Business Development Manager at the Interphoton Group. Interphoton is a Greek company based in Athens and was originally founded in 1974. Today, Interphoton operates 70 megawatt of wind and solar projects and has also a portfolio of 700 megawatt of licenses, including solar, wind, battery storage technologies, and hybrid projects.
Hello, Mr. Trambak. Thank you very much for inviting us in the show and have this interesting conversation. My name is George Limparidis. I am in charge of the operation and maintenance team, and I am working at Interphoton Group for the past 4 years.
Let's start the show with a very basic question. What has been one of the most challenging large-scale or commercial installation you have faced as an installer?
Yes, today I would like to present to you one of the most challenging projects we ever did, which was actually the first project that we as Interphoton ever constructed. It is the Mosia project. It is a project that it is located close to the city of Thebes. That project was designed in 2007 and built in 2008, which makes it the first project which ever got a production license in Greece, the first actually utility scale project and the first one to be connected to the grid. You can imagine that back then we faced several challenges at multiple levels in order to make this project a reality. It's a 2 megawatt project and it's installed on the ground with fixed tiled mounting structures.
Were there any unique environmental or logistical hurdles that you encountered during this project?
So back then we faced several challenges like lack of established regulatory framework, which caused significant delays. For example, the relevant officers in the ministry had to learn a whole new process and the new technology because solar was still unknown at that time. Also, the government had to choose which authorities they had to involve and at which stages. I have to say that, for example, back then we didn't know exactly how to treat projects that were located in environmentally protected areas.
So basically, even the government did not have a framework to handle such requests.
We had a framework, but it was applied for the first time. So it was a process of learning by doing, actually. So regarding logistical challenges, there was no developed supply chain at that time in Greece. That means that we had to travel abroad and procure equipment from other markets. On top of that, we had to procure larger stocks in order to have availability in case we need it during the construction or operation and maintenance phases. We also experienced financing difficulties because at that time solar technology was not known at all at the Greek financing system. So we were lucky enough to get financing from a state German bank, and we were able to actually do the first PV project in Greece.
Were there any unforeseen complications during this project? And if so, how did you adapt your approach in real time?
I would say that the biggest complication itself was that there haven't been any other projects in Greece. So we have to, somehow reinvent the wheel for the technology, at least in the area where we are positioned, meaning Southeast Europe. So we decided that we will produce the PV mounted systems in-house, meaning that we imported high-strength aluminium from Romania, and we did the whole process here, in Greece with local factories. For example, we created here the mold in order to cast the material, and we carried out the extraction at the local factory, which is close to Athens. This whole structure was certified by TUV for our company and for our bank.
I imagine finding a certified workforce was also a challenge, especially for a pioneering project like this.
Yes, you couldn't find any trained engineers, staff that could do this. We didn't have any experienced personnel. Regarding the foundations, what we actually did back then was we didn't use any piling method, which today is by far the most common way of installing PV panels. We used external foundations, which were made of concrete. So we did a ground improvement and then compaction and finally leveling in order then to pour the concrete and install the PV mounting system. Till today we face no issues, no damages, no oxidation or any kind of design or material failure, but it was a particularly expensive solution.
The approach sounds quite similar to a ballasted system, where concrete is used to secure the PV modules without drilling into the surface. Was that the idea behind it?
Indeed, it looks like a ballast system. We kind of improvised in several different topics. For example, we encased the AC cables into concrete channels because of, in general in Greece and in that location as an agricultural area, there is a high population of rodents like rats. In order to protect our cables, we put them inside concrete channels which could be visited, opened, and whenever there was a need to repair a cable.
From a technical perspective, what were the biggest challenges your team faced during this project? Were there any specific parameters or scenarios that proved to be particularly difficult?
As Eleni said, most of the challenges that we face today are related to the age of the project. That project was constructed at 2008. It was the first utility project in Greece. The most important setback is the aging old-fashioned equipment. Whenever a change of component is needed anywhere in that photovoltaic park, it is always a hard problem to solve, as most of the components are obsolete. Today, manufacturers have ceased the production of them, and in some cases they don't even have customer support. So tailor-made solutions need to be implemented, but we cannot avoid, in some cases, the only viable solution is to purchase new modern equipment with increase in the OPEX, serious increase. Another issue, again related to the age of the construction, is the outdated approach to information storage and management from that day. Technical details that were considered of little importance at the time of construction, such as telecommunications or multi-line wiring diagrams, detailed multi-line wiring diagrams, were poorly documented. As a result, when modifications are required on site, the absence of detailed records makes it extremely difficult and dangerous to identify the appropriate intervention point, hindering the team's efficiency.
With the rapid advancements in energy management systems and software integration, are you leveraging any EMS solutions to monitor and optimize your photovoltaic parks?
We are using a tailor-made, a custom-made solution. We designed it together with a distinguished professor of telecommunication here in Greece. And we are collecting all the data from the existing gateways that we have in the park. We have to tailor-made, custom-made this solution in order to collect all their data from these gateways, and then we are seeing we can monitor it from Athens. We don't have to be there through an open program. It's called Grafana, which help us to monitor and intervene whenever it's necessary.
If you could travel back in time, is there anything you would do differently in hindsight to make the process more smoother or efficient?
The one that I would like to be different, the most important aspect from the operation and maintenance point of view is the lack of information storage. Whenever we need to put our hands on site, it's difficult and it's dangerous because any action that we may take may hinder with many other existing functions, and we don't have an analytic diagram for all of that. So that hinders the team's efficiency and has many setbacks during the operational time.
It's been a long time since you did this project. So how has this particular project influenced your approach to other challenging installations?
We resolved several new board symptoms that the technology faced back then, and that this was avoided in all other installations, or most, let's say, that we did in the following years. We see the difference of the progress of the technology through this time. How the sector changed, how industry leaders were replaced by others. And that gives us, some comfort that we can adapt in the situations and as technology is evolving, and be present back then, be present also now, and be present in the future.
Now to a final segment, Mythbusting. Is there a common misconception about the solar energy sector in Greece that you would like to debunk?
A common misunderstanding that in general we faced in Greece is that in general renewable energy, but also solar, is expensive and is of low efficiency, which is something that is wrong.
That was a great discussion. A big thanks to both of you for joining us on Sailing the Storm. It's been a pleasure having you.
Thank you very much, Rambach. It was a pleasure being at the show.
Thank you very much. Thank you very much for having us this opportunity, for giving us this opportunity. Thank you very much.
You're most welcome. If you like the video, don't forget to like and subscribe our channel. This is your host Rambach Chatterjee for ENF TradeTV, your trusted source for all things solar.